Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 18th of Condensed Matter Physics, in which I'm going to discuss some questions. Okay, okay. So guys, also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details to your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. So question number first is, it's a good question, okay, of condensed matter physics. So question number first is, so we have been given that dispersion relation, okay, EK. EK is given, that is alpha cos kxa plus beta cos kya, okay, and plus gamma cos kza. So this is the question, this is the dispersion relation given, okay, alpha cos kxa plus beta cos kya plus gamma cos kza, and we have to find the effective mass m star at pi by a comma pi by a comma pi by a. This we need to find out. Okay, so very good question guys. So there's a formula for it, okay, for the effective mass for if it is in component of x and y z. Okay, as simple formula for m star we know, right? That is m star equal to h cut square upon del square e upon del x square, right? This we know, but it is in component, so the formula is going to be this one guys. This is going to be m star equal to m star is going to be equal to h cut square upon del square e upon, so like this, m star is going to be h cut square upon del square e upon del kx square, okay, and then h cut square upon del square e upon del kx ky. This is a formula guys, you need to note down and practice questions using this formula so that it will get so that you can easily memorize this formula. Okay, okay, kx kz, okay, and then h cut square yes, this is going to be h cut square, we can write like this, h cut square upon del square e upon del ky del k del ky del ky kx, okay, ky kx, okay, I'll write it with less space, but I'll write like this would be better. So h cut square upon del square upon del square e upon del kz ky and h cut square upon del square e upon del k z square. Okay, so this is the matrix form. Okay, so this is the effective mass formula, guys. You need to note down and memorize it. Okay, and solve a question using this formula, question related to this formula. Okay, so this is the m star. So m star equal to h cut square upon del square. So you need to how you are going to memorize it or understand it. So so m star equal to h cut square upon del square e upon del k x square. Okay, and then h cut square upon del square e will take kx first. Okay, del square e upon del kx ky, then h cut square upon del square e upon del kx kz. Okay, similarly h cut square upon del square e upon del ky kx, h cut square upon del square e upon del ky ky. So this is del ky square, h cut square upon del square e del ky kz, right? And then h cut square upon del square e del kz kx, and h cut square upon del square e del kz ky, and h cut square upon del square e kz del kz square. So this is the effective mass formula. So what we are going to do is we'll find, we have e value where we'll find del square e upon del k kx square, right? And then we'll put value in this equation. Okay, equation number 1 we can say. Okay, so now it is going to be this one. So we have this, we have given this ek is given, right? Ek is given, ek is given, ek is cos alpha cos kxa plus beta cos kya plus gamma cos kz. Okay, so we'll put the value. So so now we'll find del e upon del k. Okay, del e upon del k. So this is going to be alpha a minus alpha a sine kxa, simple differentiation, kxa minus beta a square beta a kya minus gamma a cos, my apologies, sine kza, sine kza. Okay, this is kxa. Okay, now we'll differentiate it again. So this is going to be del square e upon del k square, and this value is going to be minus alpha a square cos kxa minus beta a square sine my apologies, cos kya okay, differentiation of sine is cos, differentiation of cos is minus sine, right? So minus gamma a square sine kza, right? So now we have this value del square upon del k square, right? So here we'll put the value. So m star is going to be, I'll write in next page. So m star value is going to be, m star value is going to be this one. So h cut square upon this one, del square e upon del kx square, right? So this one. So del square e upon del kx square. Del kx square means this part. Other part is going to be 0, right? So this is going to be minus alpha. this one kx, right? So this is kx, so this is going, this only this part will work, right? Kx, if we differentiate this with respect to kx here, kx, right, if we differentiate with respect to kx, then this will only this part will remain. But if we differentiate this with kx and ky, for kx, for ky only this part, then again we'll differentiate with kx, then this value is going to be 0, right? Very simple calculation. And again for delta k, so if we differentiate this with delta kx and delta ky, so for delta kx only this value will remain, right? If we again differentiate this with respect to kz, this value is going to be 0, because this is going to be constant for kz, right? So values are going to be h cut square upon minus 2 alpha cos kxa minus 2 alpha, my apology, minus alpha a square minus alpha a square cos kxa 0 0. This is 0 h cut square minus beta a square cos kya 0 0 0 h cut square minus gamma cos gamma a square cos kz, right? So this is going to be the value. This is going to be the value for m star. Very simple differentiation. Okay, we just we have just put the value here. Okay, so we have differentiate this with respect to k, right? Kx, ky, and kz. Okay, so only these value will become 0. Only this value will remain. Simple differentiation, guys. Okay, partial differentiation. Now we need to find m star at the boundary condition pi by x equal to pi by a, y equal to pi by a, and z equal to pi by a, right? So in that case, m star, that is effective mass at pi by a, comma pi by a, comma pi by a. Okay, so this is going to be, so here you can see this. If you put pi by a here at kx, in place of kx, if you put pi by a, so that value, so at kx equal to pi by a, ky equal to pi by a, kz equal to pi by a, not xy. Okay, so if you put pi by a here, a will get cancelled, cos pi values -1, right? Similarly this is going to be cos pi -1, minus going to be plus, so alpha a square is going to be remain, right? So then this is going to be, we can take h cut square as a common. Okay, h cut square outside, so this is going to be h cut square into 1 upon alpha a square. Very simple, guys, because if cos pi value is -1, minus plus alpha a square, right? And then beta a square, gamma a square. Alpha a square 0 0 0 1 upon beta a square 0 0 0 1 upon gamma a square. Okay, so now what we can do is we can take a square outside, so this is going to be m star value is going to be m star, that is effective mass, m star value effective mass at pi by a, comma pi by a, comma pi by a. So this value is going to be h cut square of a square we have taken common, so this value is going to be 1 upon alpha 0 0 0 1 upon beta 0 0 0 1 upon gamma. Okay, so these are the values, guys. This is the value. Okay, so this is the answer. H cut square upon a square 1 upon alpha 0 0 0 1 upon beta 0 0 0 1 upon gamma. Okay, this is 1 upon gamma, guys. Okay. Okay, well, so this is the question, guys. I hope you have understood it. It's a formula based question. Okay, okay, so next question we are going to solve. Next question is question 2. This is also a good question. Question 2 is a mass, okay, masses and ionic radii, ionic radii, ionic radii of Na plus and Cl negative in NaCl crystal, in NaCl crystals are 22.99 AMU and 0.98 angstrom and 35 AMU and this and 35 AMU atomic mass unit, comma 1 angstrom, okay, respectively. Packing fraction of NaCl. So there are two part of this question. The first part is we have to find packing fraction. Packing fraction of NaCl. Okay, first this we need to find out. So what is given, guys? The question is given. This is masses and ionic radii of Na plus and Cl negative in NaCl crystal are 22.99 AMU, that the mass of this Na sodium, and 0.98 angstrom, this is the radii of sodium, and 35 AMU, 35.45, guys. Okay, 35.45 for chlorine, that is the atomic that is the mass, okay, and 1.82 angstrom, that is the radii respectively. Okay, so packing fraction of NaCl we need to find out. Okay, first one, and the options for this are 0.52, B is 0.74, C is 0.66, and D is 0.34. Okay, so these are the options. Well, so I'll solve it. So guys, we know the packing fraction of NaCl, right? APF means there are packing fraction formula we know, right? N effective that is 4, write it, N effective into that volume of Na plus volume of Cl negative upon because it's a crystal, upon A cube, that is constant, right? A cube. This is the APF, right? So I'm going to write it. So this is going to be N effective for NaCl is 4. I have already explained that NaCl rock salt in my previous classes, so you can check it. Okay. So N effective is 4. Then volume of this going to be 4 by 3, 5. We can take common. So R cube is going to be this one, R Na cube plus R Cl cube, right? Upon A cube is going to be 2 2RNA 2RNA plus 2RCl 2RNA plus 2RCl. Two RNA plus 2RCl cube. Why? Because in NaCl rock salt, we know in NaCl, I have already explained, 2RNA plus 2RCl 2R 2RCl equal to A. Okay, so A cube means this one, A. This we know, guys, you need to note down. Okay, now very simple. Now we'll put now we'll put the values here, right? So this is going to be this one, APF, atomic packing fraction. Okay, this is what we need to find out, packing fraction of NaCl or atomic packing fraction. So this is going to be 4 into 4 by 3, 5, and I'll put the value now. Okay, so I'll put the value. So value is RNA. So radius of Na and radius of Cl is given. This is radius of Na is 0.98 angstrom and radius of Cl is 1.82 angstrom, right? Have you make any mistake? No. Okay. So I'll put the value. So values are going to be this one, 0.98, this one, right? 0.98 cube. This is the radius of RNA, that sodium, and radius of chlorine is 1.82 cube. Okay, upon this one, 9.8. So it is going to be like this, 2 into 0.98 plus 2 into 1.83, 0.98 plus 1.82 cube, right? So if you solve it, so this value is going to be 0.54. Okay, or this is almost equal to 0.52, this answer. So which option is matching? This one, very simple. Okay, so option A is the correct option, guys. Okay, now second part of this question, B part. So now you need to find density of NaCl. Okay, density of NaCl. Okay, density of NaCl you need to find out. Options are given. Option A, 4.2 into 10 to the power 3 kg per meter cube. Option B is 5.2 into 10 to the power 3 kg per meter cube. Option C is 7.2 into 10 to the power 3 kg per meter cube, and option D is 2.2 into 10 to the power 3 kg per meter cube. Okay, so this is the second part of the question. Okay, so very simple guys, we know the density of NaCl. There is a formula, rho equal to N effective into molar mass upon Avogadro number Na. I have already explained this in my previous lecture. So into A cube, right? So this is the formula guys for density. You need to note down this one. So I'll just put the value. So this is a crystal NaCl. Okay, so rho is going to be value of rho, that is density of NaCl, that is going to be N effective for NaCl is 4 into mass of NaCl, right? Molar mass of NaCl. Molar mass of NaCl means this one. This mass of Na plus mass of Cl, right? So this is going to be 4 into mass of Na is 22.99 plus 35.45, okay, upon Avogadro number is Na, right? This one. Avogadro number we know, that is 6.02 into 10 to the power 23 into this one A cube, right? And A cube value we know, that is simple. I have already explained A cube, right? This is 2 RNA, right? 2 RNA plus 2 RCl, right? This one A cube I have already explained, this one. So this is 2 RNA plus 2 RCl cube, right? This is going to be 2 RNA value we know. RNA value we know, that is 0.98, right? 0.98 angstrom. It is in angstrom, guys. Okay. 0.98 plus 2 into 1.82. Okay, 1.82 to the power cube, into 10 to the power minus 30, because it is in angstrom. We have converted this into meter. So rho is going to be, if we solve it, so this value is going to be 2.2 into 10 to the power 3 kg per meter cube. Okay, so which option is matching, guys? Option D is matching. 2.2 into 10 to the power 3, 2.2 into 10 to the power 3 kg per meter cube. Okay, so this is the density. Next question, guys. Next question we are going to solve. Next question is this is also a good question, guys. Question third. So a linear diatomic chain, chain consists linear diatomic chain consists of two atoms consists of two atoms having masses 2 kg and 16 kg, right? So we need to find out the maximum frequency. We have to find the maximum frequency of optical branch okay. So this is the question, guys. A linear diatomic chain consists of two atoms having masses 2 kg and 16 kg. So I have already explained this linear diatomic chain. So linear diatomic chain, okay, of masses m1 and m2, right? So now what we have to find the maximum frequency of optical branch. So I have explained the graph for it for so for the vibration for for diatomic linear diatomic chain, okay. I have explained this. So we have to find maximum uh, frequency of the optical branch, okay. Maximum frequency of the optical branch. If you know this graph which I have explained in my lecture in condensed matter physics previous lectures when I taught this chapter, so you can easily solve this question. So I'll make this graph for you, okay. So this is graph I'm going to make. Okay, graph is like this. Okay, and then this is like this graph, guys, okay. So this is the forbidden gap, okay, forbidden band, and this is optical this is optical branch, okay, and this is acoustical branch. Acoustical, I have already explained this in detail, okay. Acoustical branch, this is acoustical branch, and this is optical branch, and this is the frequency, that is root 2c upon m2, okay. And here m2 is greater than m1, okay. And this is root this branch, this is root 2c upon m1, okay. At this point the frequency is going to be omega plus, that is equal to root 2c into 1 upon m1 plus 1 upon m2. This I have explained. So you need to know this graph, guys. So if you know this graph, you can easily solve this question, okay. Just let me give you 1 second, guys, okay. One, yeah. It's a forbidden gap, energy forbidden gap. Okay, energy forbidden gap. Okay, energy forbidden gap, or these are the values. Okay, at this point it's 0. This is omega minus, and these are boundaries like minus pi by a, and this is pi by a. Okay, and yeah, so this is the graph, guys. So this is the optical branch and this is the acoustical branch. Okay, below one is acoustical and this is optical. Very important graph, guys. I would request you, this is K. Okay, K versus omega. Okay, so dispersion relation graph for 2D, for diatomic linear chain. Okay, so here this is the uh, for optical branch, this is the minimum frequency and this is the maximum frequency, and for acoustical branch this is the maximum frequency, this is the minimum frequency. Okay, well, now we'll solve the question. Okay, so for we need to find the maximum frequency of the optical branch. Okay, and also, guys, it is given, and given value of c equal to 2 given. Okay, value of c equal to 2. Okay, so now I'll solve it. So this is the graph, guys. Please practice this graph. Okay, solve so that you can easily solve questions. Okay, and this is diatomic chain, guys. I'll show you again. Okay, this one, linear diatomic chain. Okay, this is mass m, this is mass m2, m1, m2, small mass and greater mass. Okay, so now we are going to find omega plus, for omega plus, that is maximum frequency. This we know from the graph, right? This is the omega plus equal to root 2c into 1 upon m1 plus 1 upon m2, right? So this is going to be root 2c, 2 into 2, c value is 2, right, into 1 upon 2, m1 is 2, plus 1 upon 16, right? Because in question given, right? So now we can solve it. Very simple. So if we solve it, this is going to be, if you solve it, this value is going to be omega plus maximum frequency. This is going to be 3 by 2. Okay, 4 and 16, 16 will get cancelled, and 9. This is 3 by 2. Okay, and now we will find that omega minus, omega plus minimum. We'll find omega plus minimum. Okay, omega plus minimum means this one. This is minimum. So root 2c upon m1. So this is going to be root 2c upon m1, right? Root 2c upon m1 means root 2 into c is 2 upon m1 is 2. So root 2. Okay, so this is the maximum frequency and minimum frequency for optical branch. Similarly, we can get for acoustical branch. I'm going to get for acoustical branch. For acoustical branch, omega, which is denoted by omega minus. Okay, so these frequency also you need to know. Frequency are denoted in acoustical branch is omega minus, and here omega plus. Okay, so omega minus is going to be this one, omega minus maximum. Okay, omega minus maximum. Omega minus maximum. So this omega maximum is this one root 2c upon m2. So this is going to be root 2c upon m2, and this is going to be 2 into 2c, which is 16, right? And this value is going to be 1 upon 2. Okay, 1 upon 2. And similarly, we'll find omega minus minimum. Omega minus minimum is 0 right here, right? It is 0. It's 0, right? Okay, so these are so maximum frequency, as per the question, maximum frequency is 3 by 2. Minimum frequency is root 2 for the optical branch, for this branch. Okay, and for acoustical branch, this maximum frequency is 1 by 2 and minimum frequency is 0. Okay guys, I hope guys you have understood it. Okay guys, so I'm going to stop here, and also guys I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, share my details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay guys, thank you so much. Bye now.